Welcome to Robani College of Engineering and Technology. I am Reggie, Associate Professor, Department of ECE. Today in this session we are going to discuss about radiation mechanism of loop antenna. Radiation mechanism of loop antenna. On completion of the students will be able to define loop antenna, gain, bandwidth, directivity of loop antenna. So in the second unit, radiation mechanism and descent offset, we will consider radiation mechanism of linear wire and loop antenna, aperture antenna, reflector antenna, microstrip antenna, frequency independent antenna. Loop antenna. Let us assume a loop antenna of radius A with large enough. The circumference is almost equal to one wavelength. The center of the large loop is at the origin of spherical coordinate system. It is assumed that current in the loop is uniform and in phase. The far field component can be derived from vector potential, which is a function of current distribution over the loop. As shown in the figure, we assume that two small current conducting elements are located diametrically opposite on the loop. If the dipole are too short and make the angle d5 at the center of the loop, then the length of each short pole is given by a d5. As the loop is lying on xy, only current is confined to the loop. Hence the vector magnetic potential will be phi common and other common a or a equal to 0. So loop in spherical system, consider the plane xyz, phi be the angle theta if the axis dA is equal to 0. So here the observation of point P at a distance r from the origin. Hence the infinitesimal component of the vector magnetic field in phi direction due to diametrically opposite short dipole dA phi equal to mu d by m 4 pi r, where dm is the current movement produced by short dipole. In xz plane, the phi component of retarded current movement of one short dipole dm equal to I a d phi cos phi, where I is the retarded current potential and I naught is the peak current of the loop. Cross section of the loop in yz plane, how the angle it will be. The resultant current movement dm equal to 2j ia d phi sin psi by 2. Substituting the value of dm, you will get 2j ia cos pi sin beta a cos pi sin pi d pi. So dA pi already we know, j mu ia 2 pi r cos pi sin beta a cos theta pi sin pi. Integrating the value, you will get a phi equal to j mu ia by 2 or j1 ba sin theta, and j1 ba sin theta equal to 1 by pi integral pi equal to 0 to 0 to pi sin ba sin theta cos pi cos pi. Substituting the value of a pi in this field equation, e phi equal to j omega a phi, e phi equal to mu omega a by 2 or j1 beta a sin theta. So e phi is equal to mu 2 pi ia by 2 pi r into j1 ba sin theta. So e phi equal to mu ca ia by 2 or j1 sin theta. So finally you will get the electric field component E phi equal to 60 pi ba I by r j1 ba sin theta. The magnetic field component h theta at a distance is related to E phi by internal semiconductor. H theta equal to E pi by eta E pi by 20 pi ba I 2 or j1 beta sin a. Field pattern of circular loop antenna, E phi equal to 60 pi ba I by r j1 ba sin theta and h theta equal to ba1 I r j1 beta a sin theta. So j1 equal to c lambda sin theta, c lambda equal to 2 pi by a ba. The effect of pattern of circular loop antenna. So rectified first using Bessel function curve for a pattern of loop. Here you can see there is a variation from the input to output. That is, when you take the value in terms of modulus, the far field pattern is different for circular loop. Field pattern of circular loop. Field pattern of loop will be 0.1, 1.5, 8.5 lambda. So depend upon the patterns, the analysis uniform in phase current is assumed as loop. Small loop or special case, E phi equal to 60 pi a ba I by r j1 beta a. This is the far field pattern of small loop. Similarly, h theta equal to ba I by 2 by j1 ba sin theta. For small argument of first order Bessel function, the following approximation are used. j1 of x equal to x by 2. Small loop or special case. So E phi equal to 60 pi ba I by r ba sin theta. So which is equal to 120 pi square I sin theta by r a by lambda square. H theta equal to pi I sin theta by r a by lambda square. So these are the point, or these are the special case for small loop antenna. So small loop antenna are used in so many antenna application whereby I can see the importance in the antenna design. So hence these techniques is involved, and we can compare both wire antenna, that is linear antenna, that is monopole, dipole, half wave antenna with respect to the input of the loop antenna. So the maximum questions are point number one. So what is a loop antenna? What are the special case loop antennas to find the far field region? Thank you.